Okay, we're ready for 8.1b. Here in Algebra 2, we're going to dig a little deeper into graphing exponential functions. Last time we looked at how to graph just the basic exponential function, what that is, specifically growth function, what it looks like for an equation to grow that rapidly. So today we'll look a little bit at graphing transformations, again with exponential functions, and again specifically with growth functions. So again, just one point, and graph transformations. So obviously we know that word transformation. We've done it now with parabolas, we've done it with square root equations last chapter, and we've done it with absolute value equations, all kinds of different equations. We've graphed transformations. Specifically, it just means that the original graph is now being changed based on new values that are added. So just one definition, and that is what specifically are some transformations of exponential functions. So, again, just one definition here. Let's get this in red. All right, so specifically some transformations. We'll add an equation in here to kind of show you the basic layout. So it's going to be y equals a times b, and then within the exponent here, we're going to have x minus h, and then afterwards plus k. All right, if you remember anything about transformations, you'll remember that those letters a, h, and k are letters that are used quite often, okay, in the kind of the transformation sphere. So we'll just kind of get a definition of what each one would stand for, specifically with exponential functions. They are similar to prior transformations. So just as we saw before, if you remember, a typically does something to the width, either stretches it vertically, horizontally, wider, narrower. H, remember, typically moves the vertex, the main point, left to right. And then k typically shifts the whole graph up and down. So for the value a, if it's negative, it's going to flip, or it flips across the x-axis. Okay, and then within that, we'll add this to the a part. If, and let me see if they have absolute value on here, but essentially if the, I could just use vertical lines actually, let's try this. Vertical line. Okay, so if the absolute, we'll say that's the absolute value of a is greater than 1, then we'll say that it's stretched from the x-axis. And then the other option is if the absolute value of a is a fraction. Okay, it's obviously not going to be negative, but if it's because it's absolute value. But if it's a fraction, then we will say that it is compressed. Okay, I'll slot this down in a minute. Compressed to the x-axis. Okay, so let's actually throw this underneath. All right, so if it's negative, all right, so if this value is negative, and let's just throw an example up here so that we can kind of reference the numbers as we go. So let's say we had 2 times 3 to the x minus 4 plus 1. All right, so essentially the a value is this number out front, okay, right here. So if that's greater than 1, it's going to be stretched from the x-axis. So in other words, it's going to grow more rapidly, right? It doesn't move, it's just stretched. Think about that, because we're essentially taking whatever our number was, and then we're multiplying it times 2. So we're doubling it. Whatever that point was, we're doubling it. So we're just stretching that curve. Okay, if it's a fraction, then it's compressed. In other words, it was going to be that normal exponential curve, growth curve, but then we multiply by a half or a third. So we compress it back down. All right, let's continue on with this definition. So that's the values of a. H, you're going to take the opposite sign of whatever that number is and that moves your values left or right. Okay, so we're familiar with that one. So for instance, back to our sample equation here. If we have a -4, that means the main point, which remember for these, where's our main point? It's at 0, 1. It's on the y-axis. So if there's an h value here, essentially it's going to move left to right. So in this case, rather than being at 0, 1, it's going to be over at a +4 for x. So it's going to be a 4, 1, right? Rather than a 0, 1, a 4, 1. Let's go ahead while we're at this. I think it's going to be helpful, especially since we're not here together. Just kind of draw this out. So I'm going to do my original here in dotted. Let's see how dotted goes with this thing. So essentially, remember from yesterday, here's my original curve, right? Essentially, it crosses at 0, 1. It never touches the x-axis because that acts as an asymptote, right? And then it increases or grows there at 0, 1, and it increases kind of at the same exponential rate. All right, so for this one, we already mentioned, first of all, it's stretched, okay? Now it's shifted right 4, so right away I can go right 4 here, okay? And that means that my main point is probably going to be somewhere in here. Now, we haven't gotten to k yet, so let's get k real quick. Let's go back to our definition. The k value, all right, as with previous functions, moves the graph up or down. So for this equation, back to here, I'm right 4 and it's up 1. So where it normally started is right 4, up 1. So it's now at a +2. That is my main turning point. Now the tricky part with these is that the x-axis is your asymptote, and that also can move. And that's the tricky part, is where to graph these. So let's look here. Essentially what happened is that we have our normal exponential graph, okay, which would be something like this, y equals 3 to the x, right? That's our normal parent graph. So that exponential, excuse me, let's put that x as an exponent down there. All right, so y equals 3 to the x power. That's our normal exponential graph. What happened? Well, we had some transformations, okay, similar to the prior ones. It's going to be stretched from the x-axis. It's going to be right 4, and it's going to go up 1. Okay. Before we get an example or two, let's finish out with this one. So let's get a quick table of x, y. So I probably here, if I know it's shifted right 4, let me try a 4 for x and see what happens. All right. So if I try a 4, 4 minus 4 is 0. 3 to the 0 is 1. Notice 1 times 2 is 2, plus 1 is 3. So at 4, I get a value of 3. Now let's see here. Why did I have it at 2? Oh, because it's stretched. That's why. So I was graphing this point with 4, 1, but the stretch impacts it as well. Okay, impacts it as well. So let's move this point up to 4, 3. Okay, 4, 3. So that's our main turning point. And the reason that's a little higher is because it's stretched. Okay, essentially it's doubled from where it was normally. All right, let's try a point backwards. Let's try a 3, see what happens. So again, if this is my main point, my main spot, I want to kind of get the main ones around here. So if I try to 3, I get a -1. So think about this. I then would have 2. This is 3 to the -1, or 1/3, right? A 1/3 plus 1. So 2 times 1/3 plus 1, this could be 3/3. So 3/3 plus 2/3 is 5/3, or 1 2/3. Okay, so almost 2, 1.6. So right 3, almost 2. Okay, let's try one more that goes backwards. 2 would give me now 2 minus 4 is a -2. Okay, so if I'm plugging in the 2, I get 2 times 1 over, think about this, if I had 3 to the -2, that's 1 over 3 squared. That's 1 over 9 plus 1. We're even shorter. See this? We're still over 1. Think about this. 2 2/9 plus 9 over 9 is 11 over 9. So it's 1 2/9. So it's right here. Notice what we're doing. We're approaching this value 1, but never touching. Okay? Here's one note that you want to make a note of, and I'll probably go back and type this in the definition. Okay? Is that the k value also shifts asymptote. So in other words, my whole graph, because of this plus 1 over here, okay, my whole graph is moving up 1. So notice here when I plotted my points, I got a 11 over 9, so 1 2/9. Okay, 1 2/9. That's like 1.2-ish. Okay. So the whole equation went up 1. So my new asymptote, and I'm actually going to have to graph this when I go to actually graph my curve. Rather than the x-axis, it's now at a positive 1. Okay, one more point if I did a 5. 5 minus 4 is 1, so 3 to the first is 3. 3 times 2 is 6, and is a 7. So that's a 5, and we're at 3, 4, 5, 6, 7. So it's growing rapidly like we thought right there. So here's my final curve with that sample equation that was given there. Okay, an exponential growth function. Notice, I think one of the trickiest parts is this right here. Okay, because of that plus 1, the whole graph, including the asymptote, shifts up 1. Okay, you're going to know and reference these transformations right here. If it's negative, it's going to flip. Greater than 1, it stretches. That's what happened. That's why my point was up here at 3 rather than just up 1 from where it started. And then left and right with h, up or down with k. All right, let's try 1 or 2 more examples. What if we had, I'm probably just going to write this out to make it a little easier here. So what if we had, I guess we can go blue, y equals negative 1/2 times 5 to the x minus 2. Now again, you could make a table, all right, and think about points to graph. Or you could think about your transformations and say, you know what, I feel confident enough with these transformations that I can just kind of sketch this graph. Again, you don't always have to do this, but I'm going to make our original. Okay, our original crosses at 0, 1, never touches the x-axis, something like that. I should have done a different color. That's all right. Let's do our main one in a different color. Let's do green, since we never warm up today. All right, so this equation here is going to be right 2. So I know right away I'm not going to start at 0, 1. I'm going to go right 2. Notice I didn't go up or down at all. So that means the x-axis stays as my asymptote. I didn't shift up or down at all. What did happen though? Well, it flipped. See this? The whole thing flips over. Okay, the whole thing flips over. And by doing that, by flipping it over, essentially now, because it flipped over, let me make sure I'm looking at this right. Because it flipped over, it now still doesn't approach the x-axis, but it is compressed because of the fraction. So here's my point. I'm going to go right 2. Rather than go up 1, I'm flipping over to a negative 1. Okay, and then it compresses. So rather than draw my curve something like this, I'm just going to compress everything because everything is shrunken in half. All right, so it will look something like that. Again, I could do a table, and that could verify my points. Okay, I think actually I'm going to pause, and we're going to do a kind of a part B of lesson B, and we're going to finish with this example, and then we'll probably do one more together to finish out section 8.1b. So we'll pause this video, go ahead and get the second part of 8.1b here to finish out this topic.